Alright, so here we go. This is the second part for our review for the EOG. This one is going to be the part that comes right after the calculator inactive section. So starting from this point on, we can use both the desmos.com/calculator and the desmos.com/scientific calculator, whichever one we need for any particular problem. For number 16, it says, oh right, my disclaimer, do not be watching this video right after you watch part 1. These are meant to be watched just once per day because they will be exceedingly long. Don't believe me? Look how long this one is. So for number 1, or number 16 rather, we have a square that is drawn here, and it's asking us for the value of x given these two angles. Now, it tells me that each of these angles are going to be, right down here at least, these two are going to be 90 degrees. Well, if those two angles are 90 degrees, that means these are almost certainly going to be equal to 45 degrees. So we really get to pick and choose how we want to solve this problem. We could set this equation equal to not 90, but equal to 45 degrees and solve, or we could set this angle equal to 45 degrees and then solve. Or if you really wanted to, you could set these two equal to each other, as in 2x plus 15 equals 6x minus 45. You could do this any one of those three ways and you will get the same option, or you will get the same answer. Just to prove it to you, for this one, if I subtract from 15 for both sides, we get 2x is equal to 30, divide both sides by 2, x equals 15. This one down here, add 45 to both sides, add 45, and we get 90 is equal to 6x. If you were to do 90 divided by 6, you will get 15 again. And then this setup, we could subtract both sides by 2x. We could actually even subtract both sides by 6x. I'm just doing it this way. Subtract by 2x. We have 15 equals 4x minus 45. Of course, then we add 45 to both sides, which gives me 60 on this side equals 4x, and you can guess what's going to happen. If I do 60 divided by 4, I get, once again, 15. It doesn't matter which way you try to solve this problem, you will get 15 for number 16. For number 17, this one, they don't really give you a choice. They set two equations equal to each other and ask for you to solve them. So for this problem, we're going to have to start with some distributive property. We need to get rid of our parentheses here. And I'm going to rewrite this over here just because I have more space. We have 0.25x, almost forgot the x, plus 7 is equal to 4x minus 2. Alright, so for starters, I know I'm going to have to deal with a decimal at some point. So I'm going to start by subtracting 0.25x from both sides. And that's at least going to give me a positive over here with a 7, and a positive over here with a 3.75x minus 2. I'm then, of course, going to add 2 to both sides in order to isolate my variable. And that gets me 9 equals 3.75x. And then, of course, I simply divide both sides by 3.75 to finish it off. Now, this would be hard, except for the fact that this is the calculator active section. So I just have to do 3.75. Oh, sorry. I have to do 9 divided by 3.75. And my answer comes out to be 36. For number 17. X will equal 36 for number 17. For number 18, it's asking what is the rate of change of the linear linear function that has a graph that passes through those two coordinates. Okay, rate of change, it's just referring to slope, and we can use our graphing calculator for this. We can plot these two coordinates. So we have, that is 2, 9 for one of our coordinates, and then we have another one, which is located at -1, 3, right here. And I'm going to zoom in a little bit so I can see a bit clearer. Okay, I can see things clearly enough, really, from right about here, honestly. But let's zoom out just a tiny bit. That's perfect. So, from here, we're trying to see how far over, how far up we go. Honestly, you don't need to draw the line to do this. It's a little hard to do even with being allowed to draw on the screen. All you really have to do is find the rise over the run. So, the rise, how high up does it go? It's going to be 1, 2, 3, 4, 5, 6. So the rise is 6, and the run, 1, 2, 3, the run is 3. So, rise over run, 6 over 3. Technically, because this problem does not tell you to simplify, 6 over 3 would be marked correct. If you typed in 6-3, it would mark it correct. That's not the best final answer, though. Simplifying it would be better, which if you simplified it, it would end up being, of course, 3 over 1. Or sorry, not 3 over 1. What am I talking about? That would end up being 2 over 1. But, even though that would still get marked correct, the best thing you could answer for number 18 would be 2. Just 2. You don't need to enter the slash, and it's unnecessary. You can just enter a regular 2. For number 9, it is asking which value of x satisfies the equation below, and it is another equation with variables on both sides. So we are going to have to deal with that again, and it looks like we have to do distributive property on both sides, and we are dealing with fractions. So quite the problem. We'll start with our distributive property, since that needs to be what we do first so that we can get started. So on the left-hand side, we will have 12x minus 12 times 2 is 24, plus 3x, and that's going to be my left side. For the right side, we have 1/2 times x, so that would just be 1/2 x, plus 1/2 times 6, half of 6 is 3, and plus 2. So I can combine my 3 and 2 on this side, and I can combine my 12x and positive 3x on this side. So on the left side, we have 15x minus 24. On the right side, we have 1/2 x plus 5. Now I now have to decide which side do I want my variable to be on. I'm going to subtract both sides by 1/2 x. So minus 1/2 x. And for those of you who are anxious about doing this with fractions in your head, please know these calculators do have a fraction button. So if you absolutely have to, you could do 15 minus 1/2. But you really should not need to do that. Okay? That would be 14.5 or 14.5. So 14.5 x minus 24 equals 5. Of course, from here we add a 24 to both sides. Cancels out. So 14.5 or 14.5x equals 29. And for this, you really will probably want to just use a calculator to make things a bit quicker. We've got 14 and 1/2, so 14 and 1/2 divided by, don't be afraid of how it looks. Oh, sorry, 14.5 belongs on the bottom. It's 29 divided by 14 and 1/2. So my answer would simply be 2. For number 19, x would equal 2. There we go. That's going to be number 19. Let's clear the board and move on to number 20. Now, number 20, we have two opposite angles. In this diagram, parallel lines P and Q are cut by transversal R. And they're asking what the value of x is, and these two angles are going to be, it looks like, complementary. They are both going to add together to get 180 degrees. So here, this does not mean that you will set this angle equal to this angle. Clearly, this one is acute and this one is obtuse, so they will not be equal to each other. However, I could do 2x plus 40 plus 3x minus 85, ignoring the parentheses, will equal 180 degrees. And then I can start simplifying and solving from here, which is exactly what I will do. So I'll combine those two to get 5x, and then we've got positive 40 and negative 85. Well, that's going to come out to be a negative, unfortunately for us, or fortunately. It doesn't really matter since this is the thing we'll be adding and subtracting, not dividing and multiplying. So 40 and negative 85 will give me negative 45 equals 180. We then simply add 45 to both sides. Cancels here. And we have 5x is equal to, that would be 200, and what would that be, 215 or 225? Yeah, 225. We then simply divide everything by 5. So 225 divided by 5 gives me 45. It is 45, right? Yeah, 45. So that is going to be my answer for 20, and the last problem that you have to fill in the blank for. The rest of the problems from here on out will all be multiple choice. Lucky you. For number 21, it gives us 3 points that are vertices of a triangle, and it asks for the approximate length of side RQ. Okay, well, let's go ahead and use our graphing calculator to see where these are. So we have 3, negative 2, and I'm going to label it. I'm going to label this one as point P. That way I know this one is P. This one is point Q, and it is 10, negative 2. So 10, comma, negative 2. Close my parentheses. I'll check the label button. I will label this one as Q. Third point will be R, and this is at 3, negative 8. I will label this one R. There. So I'm going to click, and so I can drag my graph, and I can see my triangle here. And the question is, what is the length of side RQ? So from R to Q, that is going to be a right angle, and we are attempting to find the hypotenuse. So this is where we're going to use Pythagorean theorem. We've got a squared plus b squared will equal c squared. So we have to go ahead and figure out what is side A, or one of these sides. 1, 2, 3, 4, 5, 6, 7. For this one, we have 1, 2, 3, 4, 5, 6. So the formula we'll be working with is we have 7 squared plus 6 squared will equal a number squared. We don't know what that number is. Now let's go ahead and clear my board, or at least clear this part of my board, and open up my scientific calculator. We have 7 squared plus 6 squared. And that is going to give me 85. So we have 85 is equal to c squared. Of course, in order to take the opposite of that, we would need to find the square root of both sides to cancel that out. All right, so we take the square root of both sides, and that's going to leave me with c, which equals, it'll be about, because this will undoubtedly become a fraction or a decimal, the square root, so we use this button right here, of 85. And that is going to give me 9.219, whatever. Let's try to estimate that. This would round down to 9. So that would be B for my answer choice. About 9 units long. For number 22, a cylindrical barrel has a height of 8 feet and a diameter of 6 feet. So it's asking for the volume of a barrel. For this one, it tells you it's a cylinder. So we've got kind of this shape going on. Okay. And it tells us that the height of this shape is going to be 8 feet. And the diameter going across the whole thing, that is going to be 6 feet. And we're trying to find the volume. In case you forgot, volume of a cylinder is simply going to be pi r squared h, h standing for height. So for volume, we need pi. We need the radius, which in our case will be 3, not 6. 6 is the diameter. Radius is half the diameter. Squared times the height, which is 8. Now we can honestly just type this directly into our calculator. It even has a pi button for us, but let's see if that pi button is doing what we want it to do. So we have pi, parentheses, 3, close parentheses, squared. Then we have open parentheses, 8, close parentheses. So the answer I get by punching all that in is about 226, and it does appear as though they want you to use the symbol pi in the calculator. So think back to when we would do all those practice problems on Delta Math, where they wanted you to use that one specific calculator. This is that same situation. They want us to use this calculator when they are telling us to do something with pi. So number 22, I got the answer to be B. Let's verify that that is correct. It is. For number 23, we have apparently another cylinder. Lucky us, we get to use the same formula. So let's see, we have a diameter again. We'll cut that in half to get our radius. We have our height, which is 42 centimeters. Perfect. So volume will equal pi times the radius squared times the height, which is 42. All right, let's go ahead and punch this into our calculator. We have pi times 12 squared and times the height, 42. So for this one, we have quite a bit of a larger number. This is going to be close to 19,000 centimeters cubed. So that will be equal to C. All right, let's go ahead and move on to number 24. A light year is defined as the distance light travels in 1 year. 1 light year is 9.46 times 10 to the 12th kilometers. A galaxy is about 150,000 light years wide. About how many kilometers wide is the galaxy? So for this one, we have 1 light year, which is that amount, and we have a galaxy that is that many light years. So we are going to be multiplying 9.46 times 10 to the 12th times 150,000. Now, there are two ways you can go about doing this, but first, let's do an experiment. Let's see what happens if we try to type this whole thing into a calculator. 9.46, so far so good, times 10 raised to the 12th power, okay, so far so good, times 150,000. So, lo and behold, the Desmos calculator can actually use scientific notation correctly. Interesting. I would be cautious about just typing it in like that in this context, mostly because I would be surprised if they kept this question in the calculator active section. This type of question is too easy with a calculator normally, so don't be terribly surprised if they move this at the last second to the calculator inactive section. Or, well, not if they did that, but they might like nuke this option and they might make it so that way it doesn't work properly. If that's the case, probably your best bet is to go ahead and convert this into scientific notations. Let's see, 1, 2, 3, 4, that'd be 5. So 9.46 times 10 to the 12th times, what did I say? 7? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. Times 10 to the 5th. So if I were doing this problem, we'd multiply these two amounts. So that would be 9.46 times 1.5. So that gives me 14.9. That's not going to work, but we'll write that for now. 14.19 times, we would simply add these two to get 10 to the 17th. But I would need to, of course, have the decimal here and just move it up to the right by 1, which means this is going to increase by 1 as well. There we go. So no matter which way you do it, it might work. I don't know. Maybe using this calculator will work next week when we go to take the EOG. I would be a little surprised if it did, but it's worth knowing that you could try to type that in. It might work. And if it works, fantastic. Alright, so for number 25, we've got a table showing the number of hours Jake studied for his math test and his corresponding grade. So he studied 1 hour, 84. Studied 2 hours, 91. Studied 3 hours, 98. In general, you can kind of see that for each hour he's studying, his grade is going up by, it looks like he went up 7 points each time. So, another student, Howie, increased his test scores 6 points for each hour he studied. Okay, well, we just observed Jake is going up by 7 points each time. So if Howie is going up by 6, that means Howie his grade is increasing by 1 less than Jake's. So let's see which answer choice represents that. Jake's test scores increased by 1 point more than Howie's test scores for each hour studied. Yeah, that kind of hits the nail right on the head. Let's see what's wrong with B. B says it's 3 points more. No, it's not 3, it's only 1. C says Howie's score increased 1 point more than Jake's. No. Howie increased by 6, Jake increased by 7. And D just has everything wrong. So, that is 25. For number 26, a rental car company charges $34 per day for a rented car. All right, well, hold up a second. So it's $34 per day for a rental car, and we have $1.50 for every mile driven. Okay, well, so plus 0.5, 0.50 for every mile. Okay, good to know. A second car company charges $20 a day, and it's 75 cents for each mile. What is the number of miles at which both companies would charge the same amount for a one-day rental? Okay, so if it's a one-day rental, this kind of changes, because now it's just 34 times 1, so we don't really need the D there or there. Okay. So what is the number of miles at which both companies would need to charge for the same one-day rental? So we're trying to see when will these equal the same thing. Well, then why not set them equal to each other? 20 plus 0.75 m. It's exactly what we need to do. So for starters, I'm going to get my variable to just one side by subtracting 0.5 miles from both sides. And that's going to give me 34 equals 20 plus 0.25 miles. Then going to subtract both sides by 20, which gives me 14 for this side, equals 0.25 m. Divide both sides by 0.25, and let's see what happens. 14 divided by 0.25. I got 56, which is A, which matches what it says in the answer key. So yes, 26, we got A, 56 miles. For 27, this is a rotation of a triangle. I'm going to use my graphing calculator to assist with this one. We have a triangle, so we have 1, 1. And I'm going to go ahead and label it as well, y as well. Doesn't take too much time. Y will be at 3, 5. Okay, so this is y. And then z will be at 5, 1. Okay, and z. Okay, so it is saying that this triangle will be rotated 180 degrees about the origin. What would be the coordinates of y, or y prime? So the old y coordinate was here. So if I rotate 180 degrees, that would be 90 degrees. That would be 180 degrees. It's going to end up somewhere down here. So we know, first of all, that the coordinates have to be a negative first, then another negative. So let's start there. What answer choices have 2 negatives? Oh, well, look at that. Only one. Nice and easy for this one. You'll also notice that the old coordinates were positive 3, positive 5, and now they are going to be negative 3 and negative 5. That's what happens when you rotate 180 degrees, or if you see another problem that has 2 reflections. When it asks you to reflect over x and then reflect over y, it does the same thing. For number 28, it is asking for the value of expressions. Oh, the value of expression 2 is 20,000 times greater than the value of expression 1. Wow, what is the value of y? Interesting. Let's see, let's have a look. Okay, that took me a moment to figure out how to best explain this problem, but the way that you're going to want to try to solve this one involves a few steps. First of all, figure out how much expression 1 could be. Substitute x with 1. That's a good starting point. If I substitute x with 1, we basically have 2 times 10, which is 20. So expression 1 would equal, say, 20. So we are trying to figure out what 20,000 times greater than 20 is. So let's find out. 20 times 20,000. we get 400,000. So we're looking for one of my answer choices to equal 400,000. Question is, which one? Lucky for us, it's multiple choice, and we have a calculator right here. Honestly, for this type of problem, the best way to do this is to just start plugging in numbers and see what works. 4 times 10 to the, let's see, 1 plus 3 would equal 4. Nope, too small. 1 plus 4 would equal 5. Oh, 400,000. So that's a 5, which would be 1 plus 4. So the answer to number 28, we get 4 by plugging in all the different answers for that one. It's not the most efficient, but it's important to note that those types of questions will likely always appear in the calculator active section and will likely always be multiple choice, at least at this grade level. For number 29, the value in dollars Y of a car X years after it was purchased can be modeled by the function 14,000 minus 875x. What is the meaning of the y-intercept in this linear model? So, we've got our graph right here. So y-intercept right here, y, x. Obviously, we can tell it's going to start way up here at 14,000. And it looks like it's going to just go down in a straight line. So they're asking, what does that y-intercept mean? What does it mean when it's at that $14,000? Well, that would be the initial value. That would be after 0 years, 0 days, how much is that car worth? It's worth $14,000. The average value is 14,000. I mean, no, because we're talking specifically about the car we bought. B, the car's value decreased. No, that's the meaning of the slope. The car decreased by $16. I don't even know where the $16 came from. It's going to be A for this one. And then last one, for which choice is y a function of x? Now, we've talked about the difference between linear function and regular function a few times, but here's the basic rundown. If it's just asking what is a function, period, that means you are just looking for the x value to not repeat. Linear function must have a constant rate of change or must be a perfectly straight line. But a function, period, just can't have the x value repeat. So if we look, good, 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 A is the answer. Good, nope, the 2 repeats. It's not good. Right here, the 2 repeats. Not good. And right here, the 6 repeats. Not good. And it's the first value that's not supposed to repeat. If the second value started repeating, that'd be fine still. It's just that that first number cannot repeat for it to be a regular function. Alright? And that is it for part 2 of these review things. As I mentioned, don't sit down and watch all of them at once. You will die from watching too much math all at once. But that is it for right now. Bye-bye.